Okay, welcome Year 9. What we're doing today is beginning a brand new topic. It's called Indices. What we'll start off with is just looking at some of a bit of a revision, I guess, from Year 8. Some of the things that we really need to know for this topic. So it's basically going through all of the material that we should know, the prior knowledge that we should know, but just as a little reminder, because it could have been quite a while ago that we studied this. So, a little introduction. You see here, what I've drawn is number 2, and we can see here it's raised to the power of 3. Now, hopefully when you see something like this, you know that this means 2 times 2 times 2 again. You might be more familiar, say, with 2 squared, and we know that is 2 times 2, we can write that. But if we were to multiply by 2 again, we would write it in this simplified form, 2 to the power of 3. With indices, we actually need to sort of fill this in a little bit further. This little letter here, this little number I should say, is called the index. Now if I was to talk about more than one of these, I don't say indexes, the plural for index is actually indices, which you'll see is the title of this topic. So one of these would be an index. When I'm talking about multiples or more than one, indices is the word I use. Another word for this is exponent. I use that word less, but it does come up sometimes, so we should be familiar with that. The index or the exponent, and of course, indices, we're talking about the same thing. This larger number here, the base number, so let's write that as well. This is the base. So the base of this term here is a 2. The index has a value of 3. Pause here and put this little diagram here into your book. Okay, what we'll do next is look at the next slide here. And what I've done is just outlined a little bit of what I was talking about before. If we've got base 2 to the power of 2, that means 2 squared, and I can write that in its full form, 2 times 2. I can do the same with 2 to the power of 3. Knowing that, how could we write 2 to the power of 5? Let's follow the same pattern. 2 to the power of 5 must mean 2 times 2 times 2 times 2 again times 2. Let's have a look. How many 2's have we got? 1, 2, 3, 4, 5. It's being multiplied by itself. 1, 2, 3. 5 2's altogether in that list. We can write this 2 to the power of 5. Let's do 2 to the power of 7 then. How many 2's are there that are being multiplied together? 1, 2, 3, 4, 5, 6, 7. As we can see, we have base of 2, and this to the power of 7 means exactly what we've written here. Hopefully this is a little bit of a revision for you. Let's have a look at the next slide. Express as a power or as a product of powers. So this time we're actually going to work backwards. Let's look at this one, 5 times 5 times 5. How could we express this? So it's a bit neater, it's a bit nicer, it's more simple. Remember, with maths, we like to simplify things as much as possible. This particular number here, we don't want to write 5 times 5 times 5. We want to actually simplify this so it's a lot shorter. The base here, the number that's being multiplied by itself, is the number 5. How many times does this number appear here? 3 times. 5 times 5 would be 5 squared. 5 times by 5 again, 5 to the power of 3. We can do this with 2 different numbers as well. I'm not actually going to multiply this out and evaluate it. We know that this has a value, so do all of these numbers here. What we're doing is expressing them as a product of powers, which you'll see up the top. That means we want to put an index here. Let's begin with this one. 2 times 2 is 2 squared. the base 5 for this last section, how many times? 3. 2 times 2, 2 squared. 5 times 5 times 5, 5 to the power of 3. This is now expressed as a power. We've got two separate ones, which is where this product of powers comes in. I'll just remove that. Okay, so the last one. Here we have 3 times 3. We know that is 3 squared. We're multiplying that by a different base. This other base is 7. 7 times 7 times 7 times 7 is 7 to the power of 4. Pause here and put these examples into your book as well. Finally, let's have a look at prime numbers. Now, before we start this, express each number as the power of a prime. We actually need to revise what is a prime number. Can you remember? I'll make a couple of little dot points, I think. First of all, a prime number is greater than 1. It's a good first step. Secondly, hopefully you remember this, it has no factors other than one and itself. So, for example, the number 2. What are the factors of 2? Well, we've only got 1 or 2. What about the number 5? What are the factors of 5? 1 and 5. What about a bigger one? Maybe 13. Can you think of any numbers that go into 13 apart from 1 and itself? There aren't any. These 3 numbers here are prime numbers. What our aim is here with this number 16, we know 16 is not prime. How do I know? Well, it's an even number, so it obviously has 2 that goes into it. So that's one factor that is not a 1, and it's not itself. So I know this one has other factors. How do I express this as a power of a prime? Well, what I'm going to do is a little factor tree underneath. So this will be a little bit of revision. I know you did these last year. Let's have a look. Can you think of 2 factors of 16? Immediately I know 2. I mentioned 2 before. What do you multiply by 2 to get 16? You multiply by 8. Can I get any factors of 2? Well, no, I know 2 is prime. So the only factors now are 1 and 2. So I'm going to leave that there. That's now prime. I'm going to put a circle around it. The number 8, can I break this down into its prime factors? Yes, I can. This does break down further. 2 times 4. Here I have another prime, so I'm going to circle that. And now I'm going to work on the 4. We know 4 has factors of 2 and 2. So I'm going to circle them. These circled numbers should be your prime numbers. So what I've got here now is 2 times 2 times 2 times 2. So what I've done here is written out these prime numbers that I ended up with at the ends of the factor tree. Now this must equal 16. 2 2s are 4, 4 2s are 8, 8 2s are 16. It does work. Finally, remember the question said express the number as the power of a prime. 2 is my prime to the power of 4. So 16 is equal to 2 to the power of 4. Let's try another one. 99. You know your times tables? You'd know that 9 times 11 is 99. Are any of these prime? 9 is not, because I know 3 goes into 9. What about 11? Are there any numbers that go into 11? Apart from 1 and itself, so 1 and 11. No. That one is prime, so I'm going to put a circle around it. I'm going to break 9 up into its factors. 9 is 3 times 3, isn't it? There's a factor, a prime factor, and there's another one. So these circled numbers are multiplied together to give 99. And finally, we'll write these as a product of powers. So this one here is 3 squared times 11. Product of primes. And the power of a prime. There we are. You may like to put these into your summary book as well. We won't do too many of these, but it is a good revision. We have to be good at our factors, obviously, and our times table, so it's important that we continue to practice those. So pause where you need to get these examples, and we'll finish up this short video just here. Thank you.